Lesson 17.1, Task 5. Solve real-world quadratic equations graphically. The distance that a falling object travels over time due to the gravity can be modeled by the quadratic function d of t equals 16t squared, where d is the distance in feet and t is the time in seconds since the object begins falling. A professional cliff diving competition uses a platform that can be set to a range of heights. Use the function d of t equals 16t squared to determine the time it would take for a diver to reach the water from the platform height shown. All right, so it gives us a platform height is at 65 feet. Okay, and you can see here's the cliff diver here. All right, so it says since the total distance the diver must fall to the water is 65 feet, solve the equation 65 equals 16t squared. So f of t, or your y value, would be 65. So you plug that in, and then you can subtract 65 to set it equal to 0, and then that way you can graph it. So write the quadratic equation as 65. Actually, they subtracted the 16t squared. So 65 minus 16t squared, it would be the same difference if you check the equation the other way. You could subtract in either direction to write a new equation, as long as you get one side equal to 0, and as long as you do the same operation on both sides of the equation. So if you subtract 65 from both sides, you set it equal to 0. In this case, they subtracted 16t squared from both sides to set it equal to 0. Once it's set equal to 0, then you can graph it. All right, so f of x equals 65 minus 16t squared. All right, so knowing that 65 is the diver's initial height and 16t squared is the distance that the diver has fallen at t time, what does 65 minus 16t squared represent? The distance in feet from the top of the cliff at t seconds after the dive, the distance in feet above the water at t seconds after the dive, the amount of time it takes for the diver to hit the surface of the water. All right, so it's going to be this one, the distance in feet above the water at t seconds, because t can change. T is your independent variable. So you may want to know after 1 second, after 2 seconds, after 3 seconds, and you could plug that in to find out what that would be. All right. All right, the distance from the top of the cliff was the initial height is equal to the distance fallen plus the distance remaining. So the initial height minus the distance fallen is equal to the distance remaining. All right, I don't know if that helps or not, but anyways, looking at the graph. So we've got f of t equals 65 minus 16t squared. All right, so it's upside down here because it's negative t squared. It's negative quadratic, so we know when it's negative, it's going to be upside down. It's got an initial height of 65, so we can see the y-intercept here is at 65. And we can see that after approximately 2.016 seconds, it's going to hit the water. And on this side, we don't have to even really look at this side because we can't have negative 2 seconds. All right, so how do you know that the given t-intercepts are approximates and not exact values? Select the words to complete this statement. All right, so if you evaluate the expression for the values of this and this, you get a distance that is close to 0. And you can check that using your calculator. Just plug that in. So if you want to see if it's going to equal 0, just do 65 minus 16. And then instead of t, we're going to put in 2.016. So we're going to put in 2.016. And then we're going to square that. Whoops. Wrong thing there. Let's go back here and delete that. Okay, so now I'm going to square it. I hit the inverse button instead of the squared button. So we've got 65 minus 16t squared, and in place of t we put 2.016. So 65 minus 16t squared. That looks correct. All right, so this is going to be exactly 0 if that's an exact solution. If it's close to 0, that's why it's an approximate. So you've got negative 0.028096. So 0.0, it's kind of close to 0, but it's not exactly 0. So we know that this is just an approximate answer. All right, so based on the graph, the t-intercepts are about -2 and 2. The solutions of the equation are t and the squiggly lines. Instead of the equal lines, if it looks like a wave instead of an equal sign, then that means approximately. That means it's close to -2 and close to 2. So it's not exact answers. So the solution t is approximately -2 is not valid in this situation. Why is it not valid? Well, because time represents seconds, and we can't have -2 seconds. So it says the distance in feet cannot be negative in the context of the problem. The solution is not exactly -2. The time in seconds cannot be negative. So that's the correct answer. The time doesn't go backwards, so it can't be negative. So therefore, it takes about 2 seconds for the diver to reach the water. So in this case, this is a real-world problem. So you are using a quadratic equation to solve to find out the answer, but only one of the answers is going to be a true solution. So sometimes you have to make sense out of what is a real solution and what will not work in the context of the problem. All right, that's all for task 5. If you have any questions, let me know.